Welcome back to my channel. So today we want to look at some acing your technical interview questions, and the question we have says find the center of of star graph. So we said there is an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center node with every other node. So you're given a 2D integer array edges where each edges I equals to ui vi, indicate there is an edge between nodes ui and vi, where to return the center of the given star. So let's see an example. So we're given this 2D integer array, and here we have the center is obviously 2. Okay, and the way it's represented is there is an edge between 1 and 2. It's undirected. So if it's between 1 and 2, so we also have between 2 and 1. Then we have between 2 and 3 and between 4 and 2. So in this case, a show node is connected to every other node, so its center is 2. In this case, center is 1. So n could be minimum of 3, at least 3. We're able to get a star, and could be up to 10 raised to the power 5. The edges is just 1 less than the number of n. We just have 2 elements inside each of the edges list. The values could be 1, that's the base value starting at 1, and it could be equals to n. And ui is not equal to vi, and the given edges represent a valid star graph. Okay, so how do we solve this problem? As we're seeing it here, we can see that the output that is returned, which is the star, is in every element. So that's an idea. 1 is see that is a return is in every element. So inside the list of lists. So that means that we can just iterate through the element of edges, and we check for element that is common throughout. Then that is the element we're looking for. So that gives us some idea. Same thing here. Okay, so are there any edge cases? We don't have any edge because the minimum we have told that it must be 3. So we're sure that we always have at least a star. And there are no repetitions as well. So they've given us that. And there are no repetitions, and the number of elements will just be exactly 2. Alright, so we got an idea of what to do. So what we need to do, we're guaranteed that we always have something to return. So if we go through this edge, how do we get the number that is present in, that is the node that is in every of these item, every of these edge in this edges list? So what we can do is, we do know that the one with the maximum, because here we have 2 here, we have 2 here, and we have 2 here. So we do know the one with the maximum number will actually be the what we're looking for. So what we can do is that we can create a list, a temporary list that we initialize the count to 0 for each of these nodes. And as we iterate through these edges, we can increment the count of that part of each of the node that we have made. At the end of the day, we just return the maximum, and that will be the node that we are looking for. So that's the idea we want to use. So let's go with that. So first we need to have a count. So this is a count list. So this one will just help us to count the nodes. And initially we need to 0. Now the length of that list must represent each of the nodes. So here 1, 2, 3, 4. So, and in that scenario, our n is going to be 4, but it's starting at 1, so we need to do a trick. Yeah, so what we actually need is we multiply this by the length of the edges, because we can't get we don't know our n, we only have the edges list, but we do know that the edges is n minus 1. Okay, so the number of edges is n minus 1. So what we do is we say length of the edges, and we can add 1 back, so this will represent all of the nodes for us. Okay, so this gives us for all of the nodes, because as we have here the length of the edges 1, 2, 3, but we need to represent 4 nodes, so we just add 1. Alright, so that's done. So what we now look at, what this one is going to give us is, because it's going to be starting at 0 and we don't have our node is not starting at 0, so we need to do something, a kind of hacking here. So what we can do is we can actually okay, we can still leave it like that, so but we need to deal with the 0 count here. So let's go ahead. So we can now go on to our edges, and we now say for edge in edges in that list. So that edge, what we do is that we increment the values. So we say count underscore nodes of, we pick the first edge because it's a tuple, and we increment that by 1. We pick the second one too, that's also the second part, and we increment that too by 1. Now we're going to have an issue here because this is going to start, we don't have the maximum value like 4 in our list. So to be able to do that, what we will need to do is we might need to decrement this one by, we'll remove 1 from here so that we can take care of these count nodes, or better still, we can actually add 1 to this plus another 1, so that we now have in excess. So we kind of have it in excess. So I'll work with that So for this one that has 1 2 3 4, what we're going to be having is 0 0 0 0, then we have 0. So this one is redundant, so that when we are using the index 1, so it will be this is 1 2 3 4, just to take care of our index. All right, so what do we return? We get the max of our count nodes, whatever count there, whatever it returns. Then we use our count nodes to get the index of that, and that will be what will be returned. Done. So let's quickly do a walkthrough. So here we have our edges as this. So this is our edges. So here this is 1 2 3, length is 3 plus 2 5, so we have 5 initialized. So our first edge is 1 2. Then what will happen is, at this stage, is going to pick count nodes of 1, so and increment that by 1. So this will be this 0 becomes 1. Then this one of 1 incremented by 1, that is 0 1. Yeah, of 2, because this is the edge 0 is 1, so this of 2, so this will be edge 2. So this is 2, this will evaluate to 2, this evaluates to 1. So 0 1 2, so this one becomes 1, and we're done with that. So the next edge is 2 3 2 3, so this evaluates to 2, this evaluates to 3, so 2, that is 0 1 2, so this one becomes 2. This is 3 0 1 2 3, so this one becomes 1. Now go on to the next one, which is 4 2 4 comma 2, and this is 4. This is 0 1 2 3 4, this one becomes 1. And this is 2, and 0 1 2, this one becomes 3. Then that's all. Then it comes to what's the maximum? This is 3. What's the index? 0 1 2, so the index is 2, and that's it. So let's run that. That works. So let's submit. Okay, thank you very much, and see you in the next one.